How does moment of inertia affect vehicle dynamics? Imagine trying to turn a heavy shopping cart filled with groceries. The more weight you have far from the handle, the harder it is to change direction quickly. That's similar to what the moment of inertia does for a vehicle. It measures how a vehicle's mass is spread out around an axis of rotation, usually through the center of gravity. This value tells us how much effort it takes to rotate the vehicle in different ways. In vehicle dynamics, the moment of inertia influences how a car responds when you turn the steering wheel, accelerate, brake, or hit bumps on the road. If a vehicle has a high moment of inertia around a certain axis, it resists changes in its rotation. That means it needs more force or torque to start turning or to stop turning. Think of a big truck versus a small car. The truck's larger mass spread out over a bigger area makes it harder to change its direction quickly. When it comes to turning left or right, the yaw motion is involved. A vehicle with a large moment of inertia around the vertical axis will turn more slowly and feel more stable at high speeds. This can be good for safety because it prevents sudden, sharp movements. But it also means the vehicle isn't as nimble. On the other hand, a smaller moment of inertia allows for quicker, sharper turns, making the vehicle more responsive but possibly feeling twitchy or less stable. The moment of inertia also affects how the vehicle handles during cornering. For example, if the mass is concentrated from the center, like a heavy engine at the front or rear, it increases the moment of inertia. This makes the car resist body roll, which is the tilting of the vehicle during turns. While this can improve comfort and stability, it might also reduce the vehicle's agility. Engineers pay close attention to how the mass is distributed when designing vehicles. They calculate the moment of inertia for the entire vehicle and its parts to predict how it will behave on the road. Moving heavy components closer to the center reduces the moment of inertia, making the car more responsive. Conversely, placing weight farther out increases resistance to rotation. Adjusting the mass distribution can help tune a vehicle's handling. For example, shifting weight towards the rear can improve acceleration and cornering. Stability control systems also use data about the moment of inertia to decide how to intervene during sharp turns or sudden maneuvers. During testing, understanding the moment of inertia helps engineers improve safety features and vehicle response. In essence, the moment of inertia controls how easily a vehicle can change its rotational motion. It affects everything from how quickly it can turn to how stable it feels at high speeds. Managing this property through design choices is key to making vehicles safer, more comfortable, and more fun to drive.